right, so today we are going to do this activity called Move the Monster. It just again talks about transformations, but this time we have a function. So this funky looking graph right here is our entire function. And so we're going to move this entire thing. This is our monster that we're going to move. Okay, and so this is going to be known as the parent function. So the parent function. And so this is where our graph starts or begins, right? That's where our graph starts or begins. And so everything is going to be based off of these points we have right here. So I just need to fill in the y value. So at -3 right here, we have 0, -1, -3, 0, 1, 1, 0, 2, 1, and 3, 0. So those are all those points that are on my monster. Okay, and so this again, consider the parent function the original where things began, right? And so what I've done is I've created this Move the Monster in a Desmos. That's also on our canvas. Okay, and so we can kind of play around with it and see what happens. So notice the original one is going to be in black, and then this new one I'm going to alter is going to be in green. Okay, so the first thing that it wants us to do is figure out what happens when we take our function, our monster, and we add 2 here at the very end outside of parentheses. So I just go to the end and I add 2. Okay, and so this basically shifted up. And so now I have a few points. So I need this point right here. Oh, dang it, I thought I could click on that. Most of these points I can click on, except for the end points for some reason. So these are the points that I need. So I have -3, 2, -3, 2, 1, -1, 0, 3. So again, I'm just grabbing these from here. 1, 2, 2, 3. And this point is at 3, 2. 3, 2. And so if we compare that, again, I can plot these on my new graph right here. -3, 2, -1, -1, 0, 3, 1, 2, 2, 3, and 3, 2. So I just connect the dots, and we can see that it shifted up 2 units. Okay, and so if I wanted to write the domain for this and the range, the domain, again, left to right, goes from -3 with a bracket because everything's solid line to +3. Again, so the domain's from there to there. The range, I'll do in red, the lowest point to the highest point, so that's -1, 2, 3. Again, both have brackets. Okay, and so there's my new graph. And again, if we compare it to our graph, we started here, we've shifted up 2. If I look at my table, the only thing that changed are my y values. And guess what changed? Everything was added by 2. So we can say, hey, we just added 2 to each y value. So the original y value plus 2. Okay. This time I'm going to move the 2. So I'm going to add 2 inside the parentheses. Okay, so I come back over here. Let's delete that 2, and let's go inside the parentheses and add 2. And so now we can see from the black graph to the green, it shifted to the left 2. Okay, so it went actually to the left. So what are those points? So the first point right here is at -5, 0. So this is negative 5, 0. Okay, we're gonna have to mark those out. I think it was a typo. And then the next point is at negative 3, negative 3. Then we have negative 2, 1. Negative 2, positive 1. Then we have negative 1, 0. Negative 1, 0. Then this one, 0, 1. And then the last one is 1, 0 again. 1, 0. And so again, I can plot these. 2, 3, 4, 5, 0. Negative 3, negative 3. Negative 2, 1. And just kind of connect the dots as I go. 0, 1. There we go. That's a little half circle right there. Okay, and then verbal translation, we just shifted. Left 2 units. Okay, so shift left 2 units. All right, and again, that's from the original graph. So if we go back to the original, there it was. We moved left 2. And then if we look at our original table right here, we notice that the thing that changed was the X number. All the Y stayed the same. And so basically, how did I get there? I took the original X value and I subtracted 2. Okay, and so what's my domain here? My domain is from negative 5 to positive 1. How did I get that so fast? I just looked at my table right here. That's the lowest value. That's the highest value in my table. And then the range, again, I look at the highest and the lowest value in my range. It looks like a negative 3 is the lowest value and a 1 is the highest value. So again, negative 3, and then I have 2 1s, but they're both the same. So they're both the highest. So just a different way to calculate your domain and range based off of a table. Okay. Then this time it wants us to change this minus to, or this positive to a minus. So let's go and see what happens when I do that. So I go minus 2, and now it's shifted to the right. And so again, I need these points right here. And so I have negative 1, 0. So this is, oops. There we go, negative 1, 0. I have 1, negative 3. 2, 1. 3, 0. Whoa. My apologies. 3, 0. 4, 1. And 5, 0. Again. This time I shifted to the right 2. So I just say right 2 units. And then again, what did I do to the X this time? I added 2. Okay, so it's kind of opposite of what we did inside the parentheses. I subtracted 2, so my original X value, I added 2. Okay, and then we can just plot this point. Negative 1, 0, 1, negative 3, 2, 1, 3, 0, 4, 1, and 5, 0. So again, the domain goes from negative 1 to 5. The range goes from negative 3 to 1. Okay. Then they want us to change this. They want us to put a negative out in front. So let's go ahead and erase the minus 2. Let's go to the front of F, and we put a negative. And so look what happened. I'm going to kind of toggle in between this. Here's our black, our original monster. And then now you can see it's a reflection over the x-axis. Okay, so now it's a reflection over the x-axis. So our first point is a -3, 0. Next point is -1, 3. Our next point is 0, -1. And our next point is 1, 0. And our next point is 2, 1. Is that -1, I mean? And then 3, 0. Okay, and so if I compare this table to my original table, okay, we noticed that the only thing that was affected were the signs of the y-axis. So we just flipped the sign, right? We multiplied it by a negative. So all that I need to show is I multiplied by -y. And then I can just graph this. And indeed, it shows that it was reflected. Okay, and so this is a reflection over the x-axis. Again, important to write down over the x-axis. And then my domain goes from -3 to +3, and my range goes from -1 to +3. Moving on. Last one, this time we want to change this number in front to a +2. So I'm going to delete that and put it 2. And this is what we call a vertical stretch. Okay, so it didn't get wider, it just got taller almost. It's going to look like it gets narrower and taller. And so now we have -3, 0. Then we have -1, -6. Then we have 0, 2. Then we have 1, 0. 2, 2. And 3, 0. Okay. And so again, comparing this to our original table, the y values, right, were just doubled. Okay, I multiplied everything times 2, so I can show, hey, I just multiplied 2 times everything to get these new points. And again, we can graph this. 0, 2, and you can tell that it did indeed get taller. So we call this a vertical stretch by a factor of 2. Okay, because that's what we multiplied by. We multiplied by 2. So what is the domain here? -3 to 3 doesn't change. The range, however, is the one that changed. This time, the low value is -6. The high value is +2. So hopefully that shed some light on transformations. If you have any questions, again, just let me know.